Here's a really neat exercise or activity to do with your Electrophorus. We're going to make a small foil ball and hang it by a thread down so that it touches the rim of the pie pan. So I need to take a small amount of thread and a small scrap of foil. I set the thread on top of the foil, and then if I wad the foil up around the thread, that makes pretty much the fastest, easiest way to have a foil ball dangling from a thread. I'm going to need to tape a straw to the top of my styrofoam handle and tape it so that the edge of the straw hangs out beyond the rim of the pie pan. Usually a couple of pieces of tape is all that's needed to hold it in place. I'm then going to take a small amount of tape and I'm going to hang my foil ball from the straw so that it's resting against the side of the pan. So when I get it there, I can trim off the excess thread so that I have a foil ball hanging down, touching the rim of the pie pan. Now, I'm going to take the pie pan off of the foam board, and I'm going to charge my board to make sure it's nice and charged. So again, when I rub it with the fur, it picks up electrons from the fur and the board becomes negatively charged. When I set the pie pan on top of the board, electrons are going to move from the bottom of the pie pan up to the rim just like before, but look at what happens to our foil ball. The foil ball is repelled by the pie pan. Well, the only way the foil ball can be repelled by the rim of the pie pan is if the foil ball is charged. Well, if the pie pan rim becomes negatively charged and the foil ball touches it, the foil ball will pick up electrons from the pie pan rim, making the foil ball negative. That negatively charged foil ball is repelled by the negatively charged pie pan. My fingers, my hand is neutral. Charged objects are always attracted to neutral. So if I bring my hand close by, the negatively charged foil ball will be attracted to my neutral hand. When it comes in contact with my hand, it will give me its extra electrons, making the foil ball neutral again. Gravity then pulls it back down where it touches the pie pan, picks up some more electrons, and then brings them back to my hand to give them to me. It keeps repeating this process over and over again until all the electrons that the pie pan could possibly give away are taken from the foil ball over to my hand. Not all at once in one big spark, but over many trips. Now it's going to keep doing this until it's taken all the electrons it can. So eventually it stops. So the pie pan has lost a lot of electrons. It's now positively charged. When I take it and move it away from the rim of the pie pan, from the charged board, the pie pan is now positively charged, and since the foil ball touched it, it's also positively charged. Well, if I bring my finger close by again, the positively charged foil ball will move toward my neutral hand. It'll come over to my hand and pick up some electrons until the foil ball is neutral. It'll then fall back down to the pie pan, giving those electrons to the pie pan. It'll keep going back and forth between my finger to the pie pan until it's brought enough electrons back over until the pie pan is neutral. Once that happens, we can put it back on the board and we can do the whole thing over again. In one sense, this is actually a static electric motor. A motor takes electrical energy and turns it into mechanical energy, or motion. The ball going back and forth between the pie pan and my finger is mechanical energy, energy of motion, and it all happened because of electrical energy. Benjamin Franklin actually invented many different types of electrical toys that ran off of static electricity.